Okay, so today's class, which is continuing on chapter 10, is about atomic structure. So the last day we learned about how to count or calculate the number of protons, neutrons, and electrons in an atom by looking at the periodic table. So now we're going to look at how you draw that. Okay, so I mentioned this the other day when in the last class I was talking about the different scientists who kind of had an impact. I mentioned Niels Bohr. So he was the one who kind of Rutherford before him told us a lot about the nucleus and the fact that it was positively charged. And he said that the electrons were outside of the nucleus, but he didn't really talk about how they were arranged. And it was Bohr that came up with this idea of shells. They're sometimes called orbitals, sometimes called energy levels. Okay, that they were kind of in little orbits. So they look like, I was saying, they look like the rings of Saturn. They're in those orbits. Okay, so electron shells are the spaces where the electrons orbit. The shells are also called energy levels, as I just said. Now, this is the important part. The first shell, so that's the one closest to the nucleus, has space for 2 electrons. The second shell has space for up to 8 electrons. The third shell has space for up to 8 electrons, and so on. Okay, and you always fill from the center out. Okay, so this is an example. So nitrogen, we just did nitrogen there for homework. So the atomic number is 7, so that means there's 7 protons, there's 7 electrons, and to get the neutrons you do 14 minus 7 and you get 7. So in the nucleus, as we said last week, the protons and the neutrons live in the nucleus. So there are 7 protons and 7 neutrons in the nucleus. You then do your first energy level. Okay, so here's my first energy level, and that first energy level has space for 2 electrons, only 2. Okay, now we have 7. So the first shell is full, and we've used 2, so there's 5 electrons left. So you draw your second shell, and in that shell you can put up to 8, and we only have 1, 2, 3, 4, 5. Okay, so here's sodium. So small number in sodium is 11. So that's 11 electrons, 11 protons. To get the neutrons you subtract, so 23 minus 11 is 12, so there's 12 neutrons. The protons and the neutrons are in the nucleus. So here they are in here. We have 11 electrons. So your first shell will only take 2. That means there's 9 left. Your next shell will only take 8. So that means there's 1 left. So you go to a third shell and you put in your 1. Okay, so I'm going to try and do one with you. Let's pick something here. We'll do silicon. So silicon is there and it's 1428. Okay, so we'll do silicon and it's 1428. So that means 14 protons, means 14 electrons. And then we do 28 minus 14, which is 14 neutrons. So if I were to draw that, you should say that it's silicon. It has 14 protons and 14 neutrons in the nucleus. Okay, now my first shell. So once I'm in shells, I'm only looking at the electrons. So I have 14 of them. Only 2 can go into my first shell. So there's 1 and there's 2. Okay, so if I take 2 off that, I have 12 left. Each shell can only take 8, so I will fill this one up. 1, 2, 3, 4, 5, 6, 7, 8. So now I've located another 8, which leaves me with 4. So I'm going to need another energy level. I know it's gone over that, but so 1, 2, 3, 4. Now if I count them up, I should have 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so that's how you fill up energy levels, and that's how you draw Bohr diagrams. Okay, you figure out the amount of electrons and you fill from the center, 2 in the first and then up to 8 in every shell after that, until you've given all of your electrons a spot. All right. Last thing then, let's pretend that didn't happen, are isotopes. So we came across this in part of the homework. I actually think it was carbon as well, where the mass number that they gave us in the table didn't match the mass number in the periodic table, and that can happen. Okay, so the atomic numbers have to stay. We talked about that. The atomic numbers are your identifiers, so they have to stay. But the mass numbers can change. So here we have, they've identified them as 3 carbons, but with 3 different mass numbers. Okay, now look at what that affects. Okay, so 6 means I have 6 protons, 6 electrons. The 6 means I have 6 protons and 6 electrons. The 6 means I have 6 protons and 6 electrons. So they're not affected. What is affected is the subtraction, which is the neutrons. So here I have 12 minus 6, which is 6 neutrons. Here I have 13 minus 6, which is 7 neutrons. And here I have 14 minus 6, which is 8 neutrons. They are isotopes of carbon. Okay, and if you look here, this is the definition of an isotopes. Atoms with the same number of protons but a different number of neutrons. Okay, which I've just explained to you. Because the atomic number doesn't change, the number of protons won't change. What is changing is the subtraction, because that's where the mass number comes into it. And as a result, now you've got different numbers of neutrons. So if you're trying to define an isotope, it has the same number of protons but a different number of neutrons. Okay, and that's it for this section. So your homework will follow, and it's largely around drawing Bohr diagrams. Okay, have a good day.